Hi there. I wanted to go through a few things on the for the syllabus, and we'll go ahead and we're going to get started here. All right. Section 5.1, exponents and their properties. Make sure that you know that the product rule, that when you're multiplying these monomials together, or even in a polynomial, that when you multiply, you add exponents when the bases are the same. Quotient rule, you subtract exponents. Remember that anything to a 0 power is always equal to 1. I'm going to see if maybe I can get rid of that shadow somewhat. And raising a power to a power, you multiply exponents on a power to a power. And then kind of a combination of all of those in one problem. Going back to this exponent of 0, just remember that if I had 5x to the 0 is very different than this right here. This is 5 times 1 because you do what's in the parentheses and then you do the exponent. Well, the exponent here, there are no parentheses, so the exponent here gives you x to the 0, which is 1, and then you multiply after exponents in PEMDAS. So the answer here is 5. Here, because the 5 is in the parentheses, it's included with the 0 power. So this one. So there's a difference between these two. So kind of make sure you understand that. And then simplifying with your exponents. And if you have any questions on any of these rules, you can look back at the notes we did for this section, or you can go back into your grade book and do review for this right here. And you can practice some of those. Now, with negative exponents and scientific notation, negative exponents change position. They don't change the sign on the term. So let's say we had 3x to the negative 2. All right. Given this right here, just like up above, the 5 is not a part of the exponent. The same here. This would be equal to 3 stays over x squared. So a negative exponent changes its position. If it's in the numerator, it goes to the denominator. So these two are equivalent statements. They are equal. They mean the same thing. It's just that being able to rewrite it as this allows us to work with it in calculus and some of the other upper level math. This would be more applicable with finding domains or finding asymptotes, things that we'll be doing in the next chapter. Also, looking at if I had x to the negative 1 over y to the negative 2. I'm not going to put any coefficients in front of this. This would be equal to y squared over x to the first. Again, the negative exponent, to get rid of it, you change the position. A numerator to denominator, denominator to numerator. That's all that is. And then be able to simplify. Again, you may want to review a few of those. Either look at the notes for this section or look at the in the grade book and review. Scientific notation. Here, just kind of interested in being able to go from scientific notation to decimal, or decimal notation to scientific notation, to go back and forth between the two. Here, you can multiply and divide numbers in scientific notation. This mainly is a calculator issue and using a calculator to solve that. All righty, 5.2. Let's look at 5.3. 5.3, be able to find the coefficient of a term in a polynomial, the degree of the term of a polynomial, and the overall degree of the polynomial. Well, let's look at a quick example. minus 3x to the fourth. Okay, it's a trinomial, but it's a polynomial. So looking at the coefficients, you've got a -3, 5, and 1. Those are your coefficients. Coefficients don't include the variable. So when I ask for a coefficient, don't put the x in there. It's just the numbers in front. And then here, the degree of a term in a polynomial. Here, the degree is 4. Here, this term, the degree is 2. Here, the degree is 0. All right, you'd have an x to the 0. Now, the overall degree is the highest power. So if you look at your leading term here, the highest exponent is a 4. So the degree of your polynomial is a 4. That has significance in the shape. If you were to graph the answers to this polynomial, as far as if you were to make this f of x or a y, and you wanted to graph x and y coordinates that work, this would be a parabola because it's even. The leading coefficient tells you it's a parabola opening down because the leading coefficient is negative. So both of these have significance in the actual graph of the function. Okay, and let's see. Know how to add, subtract polynomials, combining like terms to simplify. My only caution is that if you have a subtract of polynomials, so if you have a polynomial here and you're subtracting another polynomial, just remember that this will change the signs in the following polynomial. And then once you do that, you can add like terms. So be aware of that subtraction symbol. Know how to multiply two polynomials and simplify the results. So, you can use your FOIL method here. I think I can have enough room. Let me see if I can get rid of that. Good. All right, so here, given 2x plus 1 times 3x minus 4. If you were to multiply these two polynomials, they're two binomials, but they're polynomials, you could use the FOIL. Okay, and if there's another method that you like, that you get the right answer every time, go for it. Otherwise, you could use the FOIL. First times the first, outside, inside, last times the last. Also, you'll need to multiply 3x plus y. Sometimes there'll be more than just x's. Oh, no, that can't be. Let me make that a 9 there. Okay, one like this here, you just have an extra variable. So you'd have your 6x squared, and 2xy and 27xy give you 29xy. The last times the last is 9y squared, adding exponents when you multiply. So there may be more than just one variable. And now one more that I'm going to talk about is you may have x squared plus 3x plus 1. You may be taking a binomial times a trinomial, or a trinomial times a trinomial. In this case, we don't use the FOIL. In this case, you would take this term here times everything, this term here times everything, and then you combine like terms. So you can't use the FOIL once you go past two binomials. All right. Let's on the page here. Again, special products. Be able to use the FOIL. Really, with the special products, I don't know why it just kind of keeps focusing in and out. Let's see, 3x minus 7 squared. If you're given something like this, make sure that you write it out twice, because you have two of them that you're multiplying together, and use your FOIL method so that you don't miss out on the middle term. So that I would just, you can look at this section again, but for the most part, this is one of the ideas I wanted you to get out of that, is to rewrite it and use your FOIL. Okay, polynomials and several variables. Know how to find the degree of a term in a polynomial with several variables and the degree of the overall polynomial. So if you have y plus 2x y cubed, I'm just going to keep two terms. If I were to look at this right here, you have coefficients of 3 and 2. The degree of this term, when you want to find the degree, you add the exponents. So you get 4. If you want here, I'm going to change this. I'm sorry. I don't want those to be equal. I don't want the answers to be equal. So here, then you would add them together and get 5. Now, had I kept that, well, we'll talk about that in a second. So here, the degree of this term is 4, the degree of this term is 5. So the degree of the overall polynomial is that one. Otherwise, if I kept my original, rather than taking the greatest one, if they're both 4, I would have just used 4 as the overall degree of the polynomial. Okay, so just add them together and then pick the largest one. And if they're the same, it would just be 4. Now also be able to add, subtract, multiply polynomials with several variables and simplify your answer. And we kind of talked about that on the first page there at the bottom. Yeah. Be able to multiply those together. Okay. And just remember that when you're adding polynomials with multiple variables, that the groups have to match. So in other words, I could not add these groups together because the whole group has to match in order for you to add the coefficients in front. Great. Oh, division of polynomials. Let's go ahead and go through this one. Maybe I'll do an example of each of these bullet points. Be able to divide a polynomial by a monomial. So an example would be 12x to the 4th. Here's an example minus. We'll do 15x cubed plus 3x squared. And let's say I'm going to divide it by 3x squared. All right, in doing this, you don't have to. Some of you can do this without rewriting it, but I will rewrite it. You put your monomial underneath each of them. And then you divide it out. So when you're taking a polynomial divided by a monomial, you're just dividing it into each of those separately. In a way, we kind of do this process when we're taking out the greatest common factor and we're trying to find out what's left inside the parentheses. It's the same type of a process. But then you reduce each of these. So you've got a 4. You subtract exponents. 4 minus 2 is 2. Minus 5. 3 minus 2 is 1. And then this divided by that is 1. So, all righty, that's a monomial or a polynomial by a monomial. Let's look at long division. I'm going to get another sheet of paper. Long division. An example would be if I have 2x cubed plus 7x squared plus x minus 1 divided by 2x plus 1. Now, you guys, long division is not as easy as synthetic, and we'll do that next. The reason, so I always try to use synthetic whenever possible. The reason we cannot use synthetic on this one is with synthetic, you need a 1 here. You have to have a coefficient of 1 and an exponent of 1. We do have the exponent of 1, but not the coefficient of 1. So without the 2, I could have used synthetic division, and we'll do an example where you put a -1. It's always going to be the opposite in your box. And then list your coefficients. But because of the 2, or if this had been a squared or whatever, then we would have had to have used long division. So we're going to use long division on this one because of the 2, even though it's got a 1 there because of that 2. So we'll put 2x plus 1. Now, one thing you have to remember, just like you do in synthetic, is you have to have, like, this is 3, 2, 1, none as far as exponents. So if you're missing an exponent, you would have to put a 0x squared. Like if that wasn't there, I would put 2x cubed plus 0x squared plus x minus 1. So the powers have to be decreasing in this box here. So if you start with a 3, you'll have to have an x squared and x. It just so happens that we've got a 3, 2, 1. I don't have to add any 0x's. Okay, so I'm going to write this down. 2x cubed plus 7x squared plus x minus 1. Okay, now you start looking at this term, this first one. What do I multiply this by to get this? And it has to match in sign as well. If it's a negative, I have to make this a negative. Just all depends on what that is. All right, so what do I multiply? What am I going to multiply this by to get this? I've already got the 2. I have an x, but I need an x cubed, so I'm going to multiply by an x squared. If I take this times this times this, it'll match exactly. So I'll do that. X squared times 2x is 2x cubed because I add exponents. Now you're going to look at the 1. Then you take the x squared times whatever is here, and it happens to be a 1. X squared times 1 is plus 1x squared. So you determine what you're going to multiply by looking at this first one, but then that's when the 1 comes in, is after you start to multiply. Well, let's say you're having difficulty finding this. You can take this first term and divide it by this, and that'll tell you what this is going to be. So in other words, if you need to, you can take the first term, divide it by this. 2's cancel, subtract exponents, you get x squared. So you can use a division to see what you're going to multiply by. All right, if that helps. Okay, now, so I took the x squared times this, and then the x squared times that. Don't forget, in long division, you change the signs. In other words, it's subtraction, but because remember, when you have that subtraction, you can change the signs and add. If you've done it correctly, this seems like there's kind of blurry there. When you add these, they'll drop out, always. And then 7x squared and a minus 1x squared is 6x squared. And then you bring down, it just, unfortunately, sometimes it's just a lot of practice. Bring down the x, the next term. We do the whole thing again. What can I multiply? What can I multiply the 2x by so it matches this? Instead of matching this, now we're going to match the next line. Well, 2 times 3 gives me 6, and I want a positive 6. X times x gives me x squared. So it's going to be 3x times 2x is 6x squared. And then, so I'll go ahead and I'll multiply that. 3x times 2x is 6x squared. 3x times the 1 is plus 3x. Okay. So you determine what you're going to multiply by to match it, and then you go ahead and multiply both of those by what you decided. Change the signs and add them together. That should drop out. 1x and a negative 3x is a negative 2x. Then you bring down the next term. And you do it again. What do I multiply? What am I going to have to multiply this by to match that? Well, you've got the 2 and the x. The only thing you need is a negative. So multiply by a -1. -1 times that is a -2x. -1 times that is a -1. Change the signs and add them together. You get 0. So there is no remainder. So it actually goes into it evenly. That's it. So your answer. So where is your answer in all of this? This right here is the quotient. It's the answer in division. X squared plus 3x minus 1. But what happens if I would have had a remainder? It was 0 here, but what if I had a 10? Let's pretend that we got a 10 there instead of a 0. What do you do with this 10? Well, it's a positive 10, so you come up here and you go plus. Actually, I'd make the plus right next to it. Plus 10 over this 2x plus 1. So if you had a remainder, then you put the remainder over here. If this had been a -10, I would have done a subtraction. So that's what you do with the remainder. But in this case, we didn't. All righty, there's your long division. Let's look at, turn this page over, synthetic division. Looking at synthetic division, which is this is what you'll be using most of the time. Not always, but most of the time. I'm going to make it easy, x minus 1. All right. This one fits synthetic division, and I highly encourage you to use synthetic division if it fits. In this case, it does. So here, why can I use synthetic? Coefficient of 1, power of 1. All right, so I am going to use synthetic. So when you have synthetic, you'll have a box over here, and then you're going to list the coefficients up here. What do you put in the box? Well, it's whatever would make this 0. So if you put in a 1, 1 minus 1 is 0. Okay. If this had been x minus 2, in the box, I would have put a 2, because 2 minus 2 is 0. If this had been x plus 5, in the box, that would be over here, I would have put in a -5, because a -5 plus 5 is 0. All righty. So these are what you put in the box. It's when that would be 0. You can just look at it and tell, okay, 1. This, it would be pretty easy. All right, so now we've determined that we're going to put a 1 in our little box here. What I highly suggest you do is the highest power is x to the 4th. So I would go ahead and list those. And that way I know I won't miss them. 4, 3, 2, 1, then the constant. Okay. You don't have to. You don't have to list these up above. Sometimes it might help, though. Okay, so the coefficient in front of the x to the 4th is a 4. Okay, so I'm going to put 4. The coefficient in front of my x cubed, well, there is no x cubed, so you have a 0. Okay. The coefficient in front of my x squared is a 2. The coefficient for x, this term, there isn't one, so it's 0. My constant is a -5. So then you kind of give yourself some space and you're ready to start. The hard part's over pretty much once you get that set up. And again, just don't forget these zeros. You need them or you're going to get the wrong answer. Okay, to start out with, you drop this down underneath the line. Then now we're going to multiply, add, multiply, add, multiply, add till we get to the end. So when you multiply 1 times 4, you get 4 and put it on the underneath that next one. 1 times 4 is 4. Then you add. 0 plus 4. Then you go 1 times 4 is 4. And then you add. 1 times 6 is 6. And then you add. 1 times 6 is 6. And then you add. So now you're ready to write your answer. You've got your coefficients for the answer. Now you just have to put the variables in. Well, this first one was x to the 4th. So you're going to start with x cubed and go down. It's always 1 less power. So then you've got 4x cubed. So this has got to be an x squared. This has to be an x. They go in order. This is your constant. And that's our remainder. So we start with a 3. 3, that's a cubed, squared, x. You just go down. What do we do with remainders? Well, it's a plus 1 over, you put it over x minus 1. And you're done. Okay, it's a little bit cleaner than the long division. A few less places to make a mistake. If you're still having issues, please let me know, especially with this synthetic division one. All right. That's it for section 5.8. 5.9 functions, be able to work with the functions, be able to add two functions together. So here you would put an x in for variable and probably going to be an x. Okay, let me look at an example. Let's say that f of x is equal to 3x plus 5. No, I'm sorry. I'm going to make this the g of x. Because I was looking at the division, so I can't. It has to be some type of a polynomial to solve. Okay, f of x, we're going to say, is x plus 1 over x minus 5. There we go. All right, so let's say I wanted to find, here. I was going to come up with another one, but I won't. All right, so if you wanted to find f plus g of 0, okay. Let's say make our x's 0. How would you do this? What would be the easiest way to do this? What I would do, rather than finding this function by actually adding these two together and then putting in the 0, I would put 0 into the f function, see what you get. You put in 0 here, you're going to get 1 over a negative 5, or a negative 1/5. Then I would put 0 into the g function, put in 0 here, 3 times 0 is 0, plus 5 is plus 5. And then you will have to add those together. I don't think I put a fraction on your, but if I did, it's all right. You're going to get 24/5, because this is 25/5, getting a common denominator. So 24/5 would be that. So what I'm saying is that you can put these in separately and then add, subtract, or multiply. Okay. All righty. And now if you wanted to find the equation f plus g of a, you would put a into the f function, and you would add, I don't know why I keep doing the adding one. You would put a into the g function. And you guys haven't learned how to simplify. This is chapter 7, but that would be, you have the right idea. If it was something like this, you would just leave it. But if you can simplify it, simplify it. But in this case, we're not there yet. But that's the idea of putting a into the f, putting a into the g and then adding, subtracting, or multiplying. Okay, now let's look at domains. If you want the domains of all of these have a commonality. This one, though, may have an additional. So it may have an additional restriction on what numbers you're allowed to use. This one. But let's look at all of them right now. Let's look at these first three. In order to find the domain, you look at the domain of these two individuals. I'm gonna get another clean sheet of paper. So you would look at the domain of this. Well, this is a line. And so there's nothing you cannot put into here and have it be undefined. So this one, the domain here for this g of x is a negative infinity to infinity. You can use anything. Okay. Over here, however, in mathematics, we know that the denominator cannot be 0. You have to ignore the numerator, and that's hard for people, but you ignore the numerator in finding the domain. So the domain of this one, the denominator cannot be 0, add 5. Okay, so this domain is limited, which means all of these are going to also be limited by this. So the domain of f plus g of x is x cannot equal 5. The domain of this, x cannot equal 5, because this one didn't limit it. This one, x cannot equal 5. This one, x cannot equal 5, but this g, which is now in the denominator, because you've got I can rewrite it to look like that. G cannot be 0 with this one. So it's also x cannot equal 5 plus the 3x plus 5 cannot be 0 because it's in the denominator. And then you solve it. 3x cannot equal a negative 5. X cannot equal negative 5/3. So this one has 2. It has x cannot be 5 and x cannot be that. Alrighty. So, good. Well, let's see if you have issues, look at your 5.9, but 5.9, if you want examples of this, you'll have to go to the end of 6.1 because that's where you'll find examples of this, as I put it down here in this one for some reason. I don't know why. Okay. 6.1. Okay, we're at factoring, solving, finding zeros, finding roots. So again, make sure that you can factor, be able to find the solutions of a polynomial equation when given a graph. So if it's graphed, we'll just do one that was like on your homework. The solution, the zeros, the roots are where it crosses the x-axis. So in this case, it would be a -2 and 2. Those would be the solutions to the polynomial. If it was set equal to 0, this would be the zeros, the roots, so get used to the terminology that they all mean the same. Be able to factor out greatest common factor, look for what's in common and pull it out. Always do this, always look for this first before you do any further factoring. Factor by grouping if you have 4 terms. Remember, you group the first 2 and then the second 2 and then pull out what's in common. We've been through some of those. You can look at this section notes or those homework to figure that out. Be able to use the zero product property. So once you've set it equal to 0 and factored it, so you set it equal to 0, you pull out the greatest common factor, you factored what is left, the solution. These represent 3 numbers. When you multiply numbers together, only one of them has to be 0. You don't even have to put the 3 with this one if you don't want to. Only one of them has to be 0 to give you a product of 0. Divide by 3. 0 divided by 3 is 0. Add 5. Subtract 7. So those are your 3 solutions using the 0 product property. Tell you what, on this one, right? Oh, let me see. Yeah, I got all those. Given the roots, the solution is 0, either stated or graphically. Find the equation. I did not put this on the test because I did not have any homework problems dealing with that. I didn't think that was fair. So I'll put that one on a different one, maybe the final, I don't know. So you don't have to know that one. If you do, great. Okay, when you're factoring trinomials, look for the greatest common factor and then factor what's left. You can either use the guess and check or you can use the X box. Whatever you want. You can also solve equations, set it equal to 0, and then factor and then set each group equal to 0 and solve them. Let this video be too long. Perfect square trinomials and the difference of perfect squares. So we'd be able to identify whether or not a trinomial is a perfect square. So what you're doing is, if you're going to use the guess and check, if you're given something like x squared, we'll do an easy one. Okay. If something times itself gives you this, and something times itself gives you this, try that first in your guess and check. I mean, you could use 25 and 1 multiplied together, but I would use that combination first and try it. So then you've got your x times x, 5 times 5, everything's positive. And you do get your 10x. And the best way to write that is like that. Okay. That's a perfect square trinomial. Let's see. Difference of 2 squares. A squared minus b squared. I think, let's look at an example. 4x squared minus, let's do 25 again. Okay. This is a difference of 2 squares, which means, what does that mean actually? 2x times 2x gives me that. 5 times 5 gives me that. Okay, this only has the 2 terms, so one's minus and one's plus, because your original is missing the middle term. Middle term is found by doing the outside and the inside. So this is a positive 10x and a minus 10x is 0. So when you have a difference of 2 squares, they'll be equal. The numbers themselves will be equal, but the signs will be opposite, so that your middle term disappears. It's important to also realize that that is not factorable. So if I had 4x squared plus 25, that one cannot be done. It's got to be a difference of 2 squares, not a sum of 2 squares. Now, when you do your sums and differences of cubes, I'll go ahead and put these on your note card that you can have. So we've got a plus b. Let's see, a squared minus ab plus b squared. And then a cubed minus b cubed. And if you're having trouble with these, go ahead and look at some of the examples we did in class. You can watch the video from this section if you missed it, or go to this homework assignment in gradebook and review it. I think one of the key things to remember, here we have a difference of 2 cubes. We have a sum of 2 cubes. So you can do a sum of 2 cubes. You cannot do a sum of 2 squares, but you can do a sum of 2 cubes. Once you've determined, what the A and B are, then you just put it into the formula, remember that this cannot be factored any further, so don't try. You can look at this to see if it can, but for the most part, this will never be factorable. This one might be, maybe not. Okay, last thing then is applications of polynomial equations. So looking at this section, we can look at the homework and practice some of those. That I only put one on, and it's not really, it's not too tough of one. And if you struggled with this one or you missed this, the video for this lesson in the module, I go through some of the homework problems. All righty. That pretty much sums it up. Oh, extra credit. The extra credit, you're going to solve value equations. So if you haven't talked to me, this is from the first test. If you haven't gone over those with me, you might want to before you take this test so that you can get the extra credit. So again, make sure that you completely factor your equations. Sometimes we need to factor some part of the expression again, unless, of course, you can't factor that one, but you can factor those. So always make sure you completely factor. All righty, that pretty much kind of goes over the review. Let me know if you have any questions on any of these sections in particular before you take your test. All right, thank you. Bye-bye.